For that, we use traffic management system. Traffic management system is one of the important component of sustainable urban planning. As today's topic is about the role of geoinformatics for traffic management system, so we will see how remote sensing GIS technique can be used for sustainable urban planning and its role in traffic management system. Okay, so moving to the next slide. First, we should know what is traffic management system. What is the traffic management system is used? So traffic management is the planning, monitoring, and control or influencing of the traffic. How we are planning, how we are monitoring, or how we are controlling our traffic comes under the traffic management. So the traffic system management, in short, we call it as a TSM. It's a program that is used to increase the capacity of state and local transportation system by increasing the number of peak hour person trip by improving the existing facilities without major construction. Okay, we have to find out the peak hour. Means the peak hour having most traffic in an area. So we have to identify what is the peak hour that is having higher traffic in that area, so we can improve the existing facilities without major construction. And that all comes under the traffic system management program. In short, we call it as a TSM. Okay, so the major objectives of traffic system management is to ensure the reliable and safe operation of the transport. It is also having used for the fair allocation of the infrastructure space, road space, rail slots, other, and improving the traveling mobility. And it is also used to conserve the energy while protecting the environment. So these are the major objectives of traffic system management. Its major focus is on to provide the safe operation of the transport, to improve the traveling mobility, and also to conserve the energy, and we have also to protect the environment. Okay, so why now, what is the need of traffic system management? Because in India, traffic is heterogeneous. It is not same in every city. Each and every city in India is having heterogeneous traffics. So we are also having multimodal vehicular traffic sharing the same road space. Okay, we have to also adopt the multimodal vehicular traffic sharing the same road space, because India is a heterogeneous type of traffic. So depending on the need of local traffic problem, we need to use the multimodal vehicular traffic that can be used to share the same road space. So this is the need of the hour. This is the need of today's era, that we should focus on the proper traffic system management. It is very important when we talk about urban planning, for getting good infrastructure, for getting good healthy life in urban area. We need to focus on the good use of the traffic, so that people can move very easily. They also need to have the good mobility, and they are also having to like you can say the protect the environment. All these factors are very important. So that's why we need traffic system management. Okay, so right now, as per the World Bank data, the total number of motor vehicles on Indian roads is about 72.7 millions. Okay, and it is also reported that 3 kilometers of the road available per 1,000 population. So you can see here how much dense is the population in India, and we are having only 3 kilometers of the roads available for per 100 for 1,000 population. Means for every 1,000 person, there is only the availability of 3 kilometers of the roads. So it's obvious that we are facing the major traffic problem in most of the cities in India, because roads are very less and population is increasing day by day. Roads are not increasing. The number of roads, the length of the roads are not increasing in comparison to the growth in the population. So that's why there is a problem of the traffic congestion in most of the Indian cities. And also you can see here, we are having total 72.7 million vehicles on the Indian roads. So this is a huge amount of the vehicles moving on the Indian roads, and only 3 kilometers of the roads are available for every 1000 population. So this is the main problem for the traffic congestion in most of the Indian cities. Okay, so how this geoinformatics means how remote sensing, GIS and GPS can be used for traffic management system. It can play a significant role in each field of the traffic management. That includes providing the alternate route to road users. If some road is having high traffic, so they can provide alternate route to the road users. Also providing the necessary information to the passengers. Passengers will be updated by the current live scenario of the traffic on that road. Okay, for proper signal control, for minimizing the accidents, and for the reduction of congestion spots. So these are the major fields that needs to be explored by using remote sensing and GIS technique. It is very much important, and we know that geoinformatics having various significant capabilities to tackle this problem of traffic in India. Okay, so first is very important utilization of geoinformatics is the minimization of the accident, because in India the road accidents are very large in comparison to the other countries in the world. So accidents can be minimized through the use of GIS by generating a database of most accident prone hotspot. Okay, we can identify the most accident prone spots as a hotspot zone, so we can avoid the accidents in future, or we can minimize the accidents possibility of the accidents. And this information can be provided either in the tabular form or graphical format. So we can create a hotspot zone, we can create a area, we can visualize, or we can graphically represent the area having higher accident. So to avoid this, we can have the information which area is highly prone to the accident, which area is less prone to the accident. So we can put the signboard, we can put some display boards to convey the message to the passengers that this is the highly accident prone area, so you have to drive slow, or you have to be very careful to get to avoid the accident. And information can be provided in tabular or graphical format, and drivers become extra cautious as such spots, hence free flow can be maintained. Okay, so if driver already know that this is the hot spot, so he will be very conscious about that, he will be very careful. If he already know that this is a hot spot zone for accidents. Okay, अगर उसको पहले से बता देंगे, then it will be good, so that when driver moves on that road, he will be very much careful about the driving on that road, because he already know that this area is having higher probability of the accident. This is the hotspot zone of accidents, so he will be very uh, careful about that road. Okay, so this is the role of accident minimization. So how we can use the methodology, what kind of methodologies can be used for minimizing the roads accidents. So first one is the like the we have to get the information about the pedestrian vehicle crash data. We should have the data about the pedestrian vehicle crash and segregate the data at each location. Then we can have to compute a severity index at each location, then examine the spatial pattern of the pedestrian vehicle crash data. We will get the spatial location of the pedestrian vehicle crash data, then create a pedestrian vehicle crash hotspot map, then load the bus stop data and identify the bus stops in hotspot areas, and finally we compute the severity indices and rank the unsafe bus stops. So these are the 6-step methodologies that can be used to minimize the accidents by using geoinformatics technology. Okay, so in the next slide here, in this way we can locate the location of different pedestrian vehicle crashes, means which pedestrian crossing is having higher vehicular crashes. So these black circles are showing the location of pedestrian vehicle crashes, means where there is higher number of pedestrian vehicle crashes. Then what is the distribution of severity indices? So you can also create the severity indices. Okay, uh, so that in the each and every location having the information that which area is higher severe, which area is low severe. Okay, so it can also have the information about the location of having higher number of accidents. Then go for the next slide, pedestrian vehicle hotspot map. Okay, on the basis of severity index, you can create a hotspot map. You can create a hotspot zone that is having higher number of pedestrian vehicle crash. So these are the hotspot zones. These black circles, these black dotted circles are showing the location of having the hotspot zone of the pedestrian vehicle crashes. Means this area is having the higher probability in the past to get the accident. Okay, now after that you have to identify the unsafe bus stop. Means what at what location there is a highly probability and what location is having the higher number of accidents near to that bus stop. So you can have the information about the unsafe bus stop in that hotspot area. After creating the hotspot area, after creating the highly accident prone area, you have to identify, you have to locate the bus stops in that near to that hotspot area. So it can be considered as a unsafe bus stop. If a bus stop is available, if a bus stop is there in that hotspot area, then this bus stop can be considered as the unsafe bus stop. So at that location there should be much careful care is needed when there is a traffic or there is a driver that is moving on that road. Okay, second important component of traffic system management is a passenger information system. Means passenger will be already get the information about the traffic system on that road. Passenger information system is designed for the multimodal transit system that integrates the GIS, network analysis, and user interfering the database management. So passenger information system provides the answer like what is the location and street address, what is the optimum path based on the time, what is the optimum path on cost, what is the optimum path based on the district. Okay, what is the uh, trip making information, what is the schedule of the public transit, and what is the fare, what is the condition of the fare. So passenger information system having all this information depending on the location of that road, because we know that each area is having different type of traffic in India. So depending on the type of traffic in different cities, we may have different kinds of passenger information system. Okay, passenger information system is very important to when we are going for traffic system management. Is it clear to all of you? Any doubt here? So this is the three tier. This is the architecture for passenger information system. First, client tier, like we are the user. So there is a tier that is client tier, that is user interface, then server tier, and after application tier. So there is a three-tier architecture: user, server, and application. Okay, user, like we are the user, so we are having the client tier, then server tier, server tier having all the information related to the traffic, and application tier is having different kinds of network analyst component, different kinds of maps, different kinds of database management system that can be used by the drivers. They are who are moving on that road. This is a three-tier architecture. Passenger information system is very important. It provides us the actual traffic scenario on that road. कितने लोग उस road पे move कर रहे हैं, कितने vehicles हैं. It includes all the information. So depending on this, traffic can be managed to the next stop, or to the next bus stop, or to the next red light. This is three-tier architecture. Okay. So query procedure in a passenger information system. So how a user can query in a passenger information system? So passenger is having two options. Okay, itinerary planning or general information. What kind of information passenger require? Okay, So after under itinerary planning, they have to enter the origin and destination. Passengers have to enter the origin, they have to enter the destination, they have to enter the time and date of the travel. So they will get the information about the traffic condition on that road. Okay, and after that they can enter the maximum of the modal transfer. And when they are need only the general information about the bus timing, about the timing of the metro, about the timing of different public transport, so they can use general information component. So user query having two components. Itinerary planning means before going or before traveling you can have the information, and general information is having the information about the you can say the number of buses, number of bus stops, or you can say the what is the timing of the metro, what is the timing of the buses, what is the timing of different transport facilities in that area. Okay, so all this information is a part of passenger information system. Okay, so user, like the passenger is a user, so they have two options. They can have the information prior to travel, or they can information just on the day of the travel, depending on their need. Okay, so this is the very good example how we are using technology for passenger information system. It's a kind of app. जैसे आप यूज करते हो ओला एंड उबर. Ola, Uber, they are using same kind of procedure. Okay, when you enter in that Ola app or Uber app, origin location and then destination location, they just show you the number of drivers near to you. So you can call any of the driver, then the driver can see the exact road, exact route from destination to the origin. Okay, this is the entire procedure that can be used by different now traveling apps, Ola, Uber, and others. Okay, so now this is passenger information system. So this is a case study that is using passenger information system and geoinformatics for sustainable urban planning of India. Sorry for interruption. There was a loss of electricity. Okay. Now I'm going to. My voice is clear, visible.
Yes, sir.
Okay, there was a power cut. So I'm going to share again my slide. Wait for a moment.